All right, let's talk about the invisible engines that power literally everything. I'm talking about electric motors. They are the hidden heroes in our homes, our cars, and in the factories that build our world, but we almost never even think about them. So let's pull back the curtain, shall we? It's a great question, right? Because on the surface, they seem completely different. But the answer is really the whole point of this explainer. Every single one is powered by a very specific, specialized electric motor that's perfectly designed for its job. There is a whole world of engineering hiding in plain sight, and we're about to dive in.
So before we get into all the different types, we have to start at the beginning. You can basically split all motors into two big families, and it all comes down to the kind of power they eat, either alternating current or direct current.
The easiest way to think about it is this. AC power, that's the juice that comes out of the wall outlet. It's the heavy lifter for big industry and your large home appliances. DC power, on the other hand, is what you get from a battery. That makes it the go-to choice for anything portable or electronics that need really fine control. So you've got Team AC and Team DC, and they set the stage for everything else. Okay, enough with the theory. Let's make this real. You are surrounded by these things every single day. We're going to start with some of the most common motors you'll find right there in your own house. Say hello to the universal motor. Now, it gets its name from a pretty cool trick. It can run on both AC and DC power. But its real claim to fame? Speed. Pure, unapologetic speed. It can spin crazy fast, which makes it the perfect little helper for a ton of tools we use all the time. And here's where you see how a motor's personality just fits its job perfectly. I mean, you need thousands and thousands of RPMs to obliterate ice for a smoothie in just a few seconds, right? Well, that is exactly what the universal motor brings to the party: raw, high-speed power. So, we've seen motors that are all about going as fast as possible. But what about the other end of the spectrum? What about jobs that need absolute, pinpoint accuracy? For that, we need to meet the precision specialists. This little guy is the stepper motor, and it is the master of precise positioning. Just think about any machine that has to move to an exact spot, stop on a dime, and do it over and over again. Your office printer, complex medical gear, and you guessed it, 3D printers. They all depend on this technology. And this right here is its whole secret. See, unlike a regular motor that just spins and spins, a stepper motor rotates in these little fixed increments, or steps. It's not about smooth motion, it's all about controlled step-by-step movement. And that's the key takeaway. Without the stepper motor's uncanny ability to move the printhead to the exact coordinate for every single layer, well, 3D printing as we know it just wouldn't work. It is the unsung hero behind that perfectly printed object on your desk. Okay, so what if you need that insane precision of a stepper, but you also need to know for sure that it hit its target and can hold its ground against a force? Well, that's where the servo motor steps in. It's basically a stepper motor with a brain. It has a feedback sensor that's constantly reporting its exact position back. This closed-loop system means it can make tiny corrections on the fly, which makes it the absolute gold standard for robotics.
All right, we've gone from the super precise to the super powerful. Let's scale things way up and talk about the single most important motor that is the literal backbone of our entire industrial world.
Don't let that technical name fool you. The asynchronous motor, which almost everyone calls the induction motor, is the undisputed king. And when the source material calls it the most common motor type, that is a massive understatement. There are billions of these things running the world as we speak.
And by everywhere, I mean everywhere. The pump that brings water to your town, the fans cooling a massive data center, the conveyor belt at a shipping facility, the elevator you rode this morning, chances are they're all powered by this incredible industrial workhorse.
So why is this the one? Why is it the default choice for just about everything? Well, the reasons are brilliantly simple. Induction motors are tough as nails, they're relatively cheap to make, and because they have so few parts that wear out, they barely need any maintenance. For industry, that combination is just unbeatable. So, we've covered the everyday helpers and the industrial giants. Now, let's look at the cool stuff, the cutting-edge motors that are powering the technology of tomorrow, from our gadgets to our cars. Meet the brushless DC motor, or BLDC for short. The key word here is brushless. By getting rid of the little physical brushes that wear out in older motors, you get something that's way more efficient, super quiet, and lasts a whole lot longer. This is exactly why it's perfect for things like drones, e-scooters, and those modern whisper-quiet air conditioners. And now for the headliner, the Permanent Magnet Synchronous Motor, or PMSM. This is the absolute state-of-the-art for high-performance stuff. Its mix of insane power in a small package and incredible efficiency has made it the beating heart of most modern electric vehicles on the road today. And this chart shows you exactly why. These IE ratings are just international standards for efficiency. Bigger number, better motor. Your classic industrial motor is great, sitting in an IE3, but a modern PMSM is already at IE4 with future ones pushing into IE5. For an EV, higher efficiency means one thing and one thing only, more range from the exact same battery. It's a game changer.
So, let's put it all together. Here's your cheat sheet. The asynchronous motor, it runs our industries. The PMSM, that's our permanent magnet powerhouse, driving our EVs. The BLDC, the brushless one, is in all our modern gadgets. Steppers give us that fine point precision for 3D printing. Servos give us intelligent control for robotics, and the good old universal motor is still making our smoothies. Each one a hero in its own domain.
And that really brings us to the final thought. This huge leap in motor tech, especially with these PMSMs, is one of the main reasons the EV revolution is even happening. It really makes you wonder, as these motors get even smaller, even more powerful, and even more efficient, what currently impossible piece of technology are they going to unlock next? Something to think about. Thanks for tuning in.